Asin, Dr. Prashant Kumar Bardhan, Professor, Department of Mechanical Engineering, JIS College of Engineering, Kollam. My subject topics: Advanced Welding Technology, ME 703A, lecture number 36, Review of Welding, Advanced Welding Technology. There are various types of metal joining processes: mechanical joining, adhesive bonding, welding, brazing, and soldering. This is a mechanical joining. This is nut bolts, and this is riveting, screws, and this is adhesive bonding. This is and this is soldering, brazing. Soldering is being done here, and brazing. So, what is welding? Welding is a process of joining two similar or dissimilar metals by application of heat, with or without the application of pressure, and with or without the use of filler metal. The heat may be generated either from combustion of gases, electric arc, electric resistance, or by chemical reactions. Welding is used for making permanent joints. The application: it is widely used as a fabrication and repairing process in industries like fabrication of ships, pressure vessels, automobile bodies, offshore platform, bridges, welded pipes, sealing of nuclear fuel and explosive, etc. The use of welding in today's technology is extensive. This growth is faster than general industrial growth. General advantages of welding: a good weld is as strong as the base metal. General welding equipment is not very costly. Portable welding equipment is also available. Welding permits considerable freedom to design. Large number of metals and alloys, both similar or dissimilar, can be joined by welding. Welding can join workpieces by spot as continuous pressure type seams, end-to-end, and in a number of other configurations. Welding can be mechanized. General disadvantages of welding: welding gives out harmful radiations, X-ray, ultraviolet ray lights, fumes, and spatters. Welding results in residual stresses and distortion of the workpiece. Jig and fixtures are generally required to hold and position the parts to be welded. A skilled welder is a must to produce a good welding job. Welding heat produces metallurgical changes. The structure of the weld joints is not same as that of the parent metal. Welded joint, as many reasons, need stress relief heat treatment. Welding classifications: there are two types of welding is there. One is pressure welding, another is non-pressure welding. Non-pressure welding is fusion welding, and the pressure welding. Most of the welding is non-pressure welding, that is fusion welding. And in other categories, welding classification: oxy-fuel gas welding, air acetylene, oxy-acetylene, oxy-hydrogen, arc welding, gas metal arc, gas tungsten, plasma arc, sealed metal arc, starred arc, submerged arc, carbon arc, flux core arc. Solid state welding, diffusion welding, explosive, forging, friction, hot pressure, roll, ultrasonic welding. Resistance welding, flash percussions, projection, resistance seam, resistance spot, offset welding. Welding classification and others, other welding processes and allied processes: electron beam, electroslag, induction, laser, turbine, brazing, deep furnace brazing, induction brazing, infrared brazing, resistance braiding, soldering, soft soldering, and hard soldering. Welding processes. One is fusion welding, involves melting and solidification. So most of the welding is fusion welding. And another welding is solid phase welding. That is explosive welding, diffusion welding, friction welding. This is friction welding, and this is fusion welding. This is fusion welding also. Fusion welding. Types of fusion welding: gas welding, arc welding, TIG, MIG, flux core arc welding, submerged arc welding, etc. Thermite welding, spot welding. Precision welding, electron beam welding, laser beam welding, ultrasonic welding, or plasma arc welding. Fusion welding, most commonly used processes: heat source, electrical arc, gas plane, laser. Filler metal from electrode, rod, wax, powder, fluxes, independently added filler, no filler, autogenous welding. This is the uh, wax and electrodes, and this is flux, and this is agglomerated flux that is used for submerged arc welding. Welding. American Welding Society, as per the definition for welding processes, is a material joining process which produces coalitions of materials by heating them to suitable temperature, with or without the application of pressure, and with it or without the use of filler material. Filler, if used, has a melting temperature similar to the parts being joined. Elements of welding processes, that is, these two part joints, that is weld joint, and two parts are joined by, this is fusion joint, and this is root, and that is root opening part joint. This is fillet weld, that is corner joint, toe, this is toe, and this is weld face, and this is root. Butt joints. Joint types: double welded part, permanent or temporary backing, single welded part. Lower test consultation, easier ultrasonic testing, and radiography, expensive preparation. This is the butt joint, butt weld types, different butt weld types: single V, single bevel, double V. This is back cuff, and this is butt joint. This is This is butt joint. This is a angle, input angle, fusion face, and this is root gap, root face. This is a root run, cap, reinforcement, two plates of joint. Fillet weld, simple to assemble and weld. Stage considerations at toe and root, notch at root, fatigue and toughness. Critical dimension is throat thickness. Root gap affects throat thickness. Radiography and ultrasonic testing is of limited use. Large fillet are uneconomical. Fillet joints. This is root and root, root face, toe, weld face, and toe. This is also leg joints, leg length. This is joint. Caps shall be taken into account for minimum leg length. Welding positions: flat position, horizontal position, vertical position, and the overhead position. This is the horizontal position. This is there to horizontal. This is overhead positions. Welding position: flat and downhand welding, horizontal welding, vertical welding, and overhead welding. These are the figure: flat, horizontal, vertical, and overhead. Type of welding joints: butt joint, lap joint, corner joints, T joint, H joint. This is lap joint. Butt joint already shown you. earlier. This is corner T joint. This is H joint. This is a corner joint. This is basically bar joint. Type of welding joints. This is bar joint, 60 degree, and single U joint, double V joint, double U joint. Other types of welding joints, corner joints, H joints, and T joints. This is the basic welding symbols. There are 22 symbols are there. So fillet joint, square bars, yeah, all the symbols are there. These will symbols are given in the drawing design. So designing engineer or welding engineer will, from the symbols, they will select the uh, type of welding to be done in the software. Basic welding symbols. Gas welding. The equipment used for gas welding, gas cylinders, black and red, hoses, blue and red, pressure regulators, welding torches. This is the two cylinders, black and red. This is red is acetylene, and black is oxygen. This is blue hoses. Pipe is one is blue and one is red. Red is for acetylene and blue is for oxygen. Pressure regulator, these are the pressure regulator. This is used in the cylinder for checking the pressures. This is the welding torch. This is the two knobs. One is green is for oxygen and red is for acetylene. This is the pressure regulator. This is the switch for releasing the gases, mixture of gases. Type of gases, types of gas flames. Neutral flame. This is neutral flame. This is neutral flame. This is oxidized flame. This is reducing flame, carbonizing flame. And this inner core temperature is 3300 degrees centigrade. Use of the flux in welding. Flux is used to protect the weld from the atmosphere. It helps with heat transfer from heat source to metal surface. And it also helps in the removal of surface metal waste. Flux produces a gas seal over the liquid portion of the weld during the welding process. Flux then form a protective layers over the weld called slag. Flux also act as a deoxidizer, pulling oxygen and nitrogen from the weld pool to the surface and preventing porosity. It helps to join filler metals to the base metals. It provides a protective barrier against igniting. Manual metal arc welding equipments in the AC or DC arc welding machines, power sources, electrode with electrode holder, arcing can, and welding leads, connectors. These are the connectors, and this is the electrode holder, electrode holder, and this is the connector, leads, welding leads. This is the circuit of this is the workpiece, and this is welding AC/DC machine, and this is the electrode holder, and electrode, and arc is formed. This is workpiece. This is the basic arc welding circuit, and as the arc welding is being done, arc is gaseous weld molten metal. This is molten metal, and base metal. This is the slag of proportion of the weld after the weld. This is slag, and this is weld. This is a electrode with cover, electrode with flux cover, flux covered. An arc is generated between two conductors named cathode and anode, functioning direct current DC. When it is separated, the air between the electrodes is ionized by the potential difference, and that reduces electrical resistance of the air column. An arc is a sustained electric discharge through this ionized gas column called plasma between the two electrodes. The arc produces a temperature of about 6,500 degree Fahrenheit, 3,600 degree centigrade at the T. This, this heat melts both the base metal and the electrode, producing a pool of molten metal, sometimes called the catter. The catter solidifies behind the electrode as it is moved along the joint. The result is a fusion bond. Welding polarity, this is state polarity, and this is reverse polarity. State polarity, electrode negative, workpiece positive. Heat is generated one third in the electrode, two third in the base metal, and reverse polarity is just opposite that, two third in the electrode, one third in the heat. The deep penetration is done in the state polarity, reverse polarity, shallow penetration. This is the AC, and AC is used, alternate current is used. This is a uniform penetration. Polarity and current flow, this is already reverse polarity, electrode negative, positive, reverse polarity, and state polarity, electrode negative. That are already shown in the last figure. It's anode and cathode. It's a cathode and anode. Ions are movement. T welding. In T process, the arc is formed in between the pointed tungsten electrode and the workpiece in an inert atmosphere of argon or helium. T process is ideal for high quality precision work. Equipment, tungsten electrode, welding machine, constant current, AC/DC, torch or electrode holder, shielding gas supply, argon, helium, or mixture of both, filler metal rod if required. This is a tungsten electrode and the filler rod. This is filler rod, and the welding arc is showing. This is the circuit of the thing. This is the workpiece, and this is a welding torch. Tungsten, this is gas supply. Cooling is required, and this is argon shielding gas, maybe argon or helium, and this is the power sources. This is connection to the workpiece and connection to the torch. TIG welding, how the welding is performed. This is non-consumer electrode, gaseous nozzle, and current conductor. This is and direction of travel. Welding rod, this welding rod, and this is arc is being done, and this is the welding direction of travel in this way. So welding rods and guide. This is guide. TIG welding equipments, DC welding machines, electrode wire electrode wire reel. This is electrode wire reel. This is electrode wire reel. Wire tubing unit, drive unit, sealing gas cylinder, welding torch. This is a circuit of the MIG welding circuit. MIG welding is performed. Gas nozzle, gas sealing gases are there. The filler rod, electrode is continuously fed, and metal droplets. This is the arc is formed, and weld metal. This is weld metal. This is base metal. Difference between TIG and MIG welding. TIG and MIG. TIG welding, non-conductive tungsten electrode, which is slowly fade into the weld part. MIG uses a continuously feeding spool of welding wire that bonds and melts and fuses both the base metal and pellet metals together. TIG welding is more commonly used for thinner gauge material. A range of material thickness can be welded from thin gauge to direct metal, sheet metal, right up to heavier structural plate. Slow, fire, and delicate welding technique. Faster welding is done through MIG. Complex require more skill, costlier than MIG. User friendly. MIG is faster welding than productivity is higher in MIG. User friendly, equipment are more accessible and is less costly than TIG. Submerged arc welding equipment welding head, feeds, flux and feeder metal, flux hopper. This is flux hopper. This is our continuously fed electrode wire and the flux continuously fed fluxes and electrodes. These are the equipments. This is a flux is given and the arc welding is done. For thicker material, submerged arc welding is preferred. Plasma arc welding or supply DC, high frequency generator or current limiting registers, arc ignition, plasma torch, cylinder gas supply, gas or cylinder, voltage control, fixtures. This is the tungsten electrode and this is plasma gas. This is plasma gas and the cylinder gas. This is cylinder gas and this is the arc, plasma arc. This is cooling water. Plasma arc welding process characteristics. Plasma welding is very similar to TIG welding as the arc is formed between the pointed tungsten electrode and the workpiece. However, by positioning the electrode within the body of torch, the plasma arc can be separated from the sealing gas envelope. Plasma is then forced through a fine bore copper nozzle, which constricts the arc. This is the comparison between TIG and versus plasma. This is the TIG and this is plasma. This is and this is the plasma arc. And the difference between this, the arc length in plasma, this is the arc length, and the arc length in TIG is smaller comparative to plasma arc welding. So deep penetration is very much can be done by the plasma arc welding. Stud welding, a high-speed metal fastening process is in which a metal fastener can be applied by a welder arc to another piece of metal. Equipment, power supply, stud welding gun. Gun is there, and this is the stud. Through the gun, arcing is done, and pressure is given. So joining process is done. Electron beam welding is a fusion welding in which coalescence is produced by heating the workpiece due to impingement of the concentrated electron beam on high kinetic energy on the workpiece. As the electron beam impinges the workpiece, kinetic energy of the electron beams convert into thermal energy, resulting in melting and even evaporation of the material. Electron beam welding equipment, electron gun, power supply, vacuum chamber, workpiece handling device. This is schematic of an electron beam gun used in electron beam welding. This is the arc. This is the beam. Electron beam gun use. Advantage of electron beam welding: high penetration to heat can be obtained, which is difficult with other welding processes. High welding speed is obtained. Material of high melting temperature can be welded. 4. Superior weld quality due to welding in vacuum. 5. High precision of the welding is obtained. Number 6. Distortion is less due to less heat effect control. 7. Dissimilar material can be welded. 8. Low operating cost. 9. Cleaning cost is negligible. 10. Reactive material like beryllium, titanium, etc. can be welded. 11. Material of high melting point like columbium, tungsten can be welded. 12. Inaccessible joints can be made. Very wide range of thickness can be joined from 0 to 5 millimeter to 100 millimeter. Disadvantage of electron beam welding: very high cost, equipment cost, high vacuum is required, high safety measures are required, large shops are difficult to weld, skilled manpower is required. Application of electron beam welding. Electron beam welding process is mostly used in joining of refractive material like aluminum, tungsten, ceramics, etc., which are used in missiles to in spite of in space shuttle application, wherein reactive materials like beryllium, zirconium, titanium, etc., are used in high precision welding for electronic components, nuclear fuels elements, special alloy jet engine components, and pressure weld vessels for rocket plants. Dissimilar material can be welded like invert that nickel iron alloy with stainless steel. Solid state welding. Solid state welding is a group of welding process which produces coalesces at temperatures essentially below the melting point of the base material being joined. Without the addition of blazing filler metal, pressure may or may not be used. Solid state welding, forge welding, cold welding, friction welding, explosive welding, diffusion welding, ultrasonic welding. Resistance welding, resistance spot welding, resistance seam welding, that is, that is resistance seam welding, this is spot welding, this is spot welding, for example, power supply, direct energy type or stored energy type, welding machines, rocker arm base type, this is rocker arm base type, and spot welding electrode, copper alloy, this is copper alloy electrodes. Resistance seam welding, this is resistance seam welding, continuous welding is being done, this is a machine, power supply, and the electrode force and support, electrode or workpiece drive. Laser beam welding, laser beam welding is a welding process which produces coalitions of material with the heat obtained from the application of a concentrated coherent light beam impinging upon the surface to be joined. The laser beam is a coherent single phase light of a single wavelength monochromatic. The laser beam has low beam divergence and high energy content and thus will create heat when it strikes the surface. Laser beam welding. Laser beam welding is a welding technique used to join multiple pieces of metal through the use of laser. The beam provides a concentrated heat source, allowing a narrow, deep welds high welding depths. The process is frequently used in high volume applications, such as in the automotive industry. It is based on keyhole or penetration mode welding like electron beam welding. Electron beam welding. Laser beam welding has high power density on the order of a 1 megawatt per centimeter square, resulting in small laser heat effective zone and heating, high heating and cooling rates. The spot size of the laser can vary between zero point 0.2 millimeter to 30 millimeter, though only smaller sizes are used for welding. Ultrasonic welding. Ultrasonic welding is a process whereby high frequency ultrasonic acoustic vibration are locally applied to workpieces being held together under pressure to create a solid state welding. It is a process that uses mechanical vibrations above the audible range. The vibration produced by welding, sonotone, or horn, as it as it is generally known, are used to soften or melt the thermoplastic material at joint line, used for plastic and especially for joining dissimilar materials. Ultrasonic welding, frictional heat produced by the ultrasonic waves and force is used for joining process. Ultrasonic waves 15 to 16 kilohertz are transferred to the material under pressure with a sonometer. Welding time is lower than 3 seconds. This is a sonotron. This is sonotron. This is a sonotron. The welding is done. This is ultrasonic welding, principles of ultrasonic welding. This is also figure of ultrasonic welding. Ultrasonic welding advantages, it can be applied to miscellaneous combustion of material welding and allow welding of thick and thin sections. Simplified welding of high and heat conduction material such as copper, gold, aluminum, silver, etc. The pressures used for welding are low along with low consumption of power. The time taken for welding is less and the width of the deformed are as thinner than that for the cold welding. Disadvantages: ultrasonic metal welding needs more power with a workpiece as width and hardness increase exponentially. This welding process is limited to lap joints. It is dependent on material deformation under cooling. It might create audible noise from parts resonance. Ultrasonic welding applications, manufacturing of toys, joining of electrical and electronic components, welding aluminum wires and seats, mobiles, sports shoes, laminations, cars, computers. This is a ultrasonic welding, ultrasonic spot welding in a wing of a auto. This is this is aeroplane, aerospace industries. They are using ultrasonic welding. Solid state welding processes, resistance rod welding, 1905, friction for polymeric material, 1945, friction for metals, 1956, explosive welding, 1963, ultrasonic welding, 1965, resistance sieve, 1967, friction steel welding, 1991, friction plunge, 1992. Various friction welding processes, conventional friction welding, friction welding, friction plunge welding, and this is friction steel welding. Friction steel welding is widely used nowadays. This is conventional friction welding. One is fixed, another is movable. This is rotating, and this is non-rotational chuck, and this axial movement is there. So this is joined together, and this is now this is joining. This is stopped, rotation stopped, and this is frictional heat and pressure by giving pressure. Joining is made. This is joining. Stages in conventional friction welding. One component is loaded into rotational headstock chuck, and the other component is loaded into a fixed tailstock. The head is accelerated to a present speed. Shape of the friction zones in friction welding as a function of the axial force applied and the rotational speed. Advantages of friction welding. The combination of fast joining times on the order of a few seconds and direct heat input at the weld interface yields relatively small heat affected joint. Friction welding technique is generally melt free, which avoids grain growth in engineered material such as high strength heat treated steel. Motion tends to clean the surface between the material being welded, which means they can be joined with less preparation. It allows dissimilar materials to be joined. Weldability, the capacity of a material to be welded under the imposed application conditions into a specific suitability design structure and to perform satisfactorily in intended surface. Factors affecting the weldability is often considered to be a material property. However, the effect of other materials should not be ignored. Weldability is also affected by design of weld, service conditions, choice of welding processes. Design, weld joint design and execution, thickness, location, access, environment, restraint, service stresses, safety factor for welds. Physical properties, melting and evaporation temperatures, electrical and thermal properties, conductivity, expansion coefficient, thermal capacity, latent heat, ionization potential of electrode, magnetic susceptibility, refractability, also factors. Chemical properties, affinity of metal for oxygen, nitrogen, and hydrogen, susceptibility to porosity, embrittlement, presence of surface film on base metal, oxide films, paint and metallic surface coating, fluxing, deoxidizing properties of a slag, contaminant gases, nitrogen and oxygen from air, hydrogen from moisture in the air, moisture in a consumables or surface contaminants, organic materials, grease, oil, and paints, gas metal reactions, liquid metal may react with air or other gases, depends on liquid metal compositions, gas compositions, consequences, porosity, gas release on solidification, formation of compounds, embrittlement, metallurgical properties, strengthening mechanism of base material, weld versus base metal strength, freezing range, susceptibility to a solidification cracking, susceptibility to detrimental phases forming during welding, embrittlement or corrosion, service environment, extreme environment, corrosive, low temperature, brittle failure, high temperature, oxidation, heat, embrittlement. Others were fatigue and nuclear. More extreme the environment, more difficult it is to find suitable materials. More restrictive the welding procedures become to avoid service failure, arc energy, welding variables, arc energy, heat input, preheat and interface temperature, filamental compositions, speed of welding. Preheat and interface. Preheat is applied independently. Gas torch, gas radiant heaters, interface temperature, temperature before next pass is added, controlled by a cooling time or air water cooling. Fusion weld structure. This is a this is heat affected zone. This is fusion zone. This is columnar grain size of fusion zone. This is heat affected zone. Grain structure, coarse grain, and finer grains. Heat affected zone. It is adjusted to weld metal zone and composed of barren metals which did not melt. Heated to high enough temperature for a sufficient period that grains growth occurs and change in microstructure. Effect of has altered mechanical properties, altered microstructure, weakest area of the weld, thermal has region. This is the thermal has. This is the heat effective zone. Heat effective total. Then fine grain structure. This is coarse grains. This is um, weld. This is a weld zone. Weld metal and subcritical has. This is base metal. Has microstructures. This is weld zone. This is weld. This is coarse grain. This is fine grain. Then this is original base metal distributed microstructure. Welding defects and discontinuities. This is the different defects, patterns. This is patterns. Welding discontinuities. Discontinuities are essentially defects that fall within the limitations of the welding standard requirements. Cracks, never a discontinuity. Porosity, most common comply weld defects. Incomplete fusion includes inclusions, some allowed by most welding standards. Defective profile, underweld, overweld, lack of core head, burn through undercut, scattered, etc. Most client specification limit these types. Welding defects causes cracks, solidification, and liquidation causes porosity, gas entrapment, rejection, poor sealing, incomplete friction, sidewall, inter run, root pass, weld, weldo, cold lap, electrode angle implemented or poor joint profile. Inclusion slag, oxide, tungsten. Tungsten is inclusion during the TIG welding, usually upper dust induced. Defective weld profile finish is underweld, overweld, lack of root bit, burn through undercut, usually upper dust induced. So skill operator is also important for to minimize the defect. Welding defects occurs causes spatter, excessive current, long arc flow, electrode coated with improper flux ingredients, undercutting, wrong manipulations, and inclusions of electrode, too large electrode diameter, higher currents, overlapping, lower arc current, slower arc travel speed. This is a defects. Some weld defects. This is a incomplete penetration. Undercut. This is undercut. Cold lap. This is incomplete sidewall. This is incomplete sidewall, and this is incomplete fusion. Solidification diagram, low melting point constituents, sulfur, phosphorus, tin, lead, navium, undesirable eutectics, grain boundaries, segregation of sulfides, etc., lower ductility or raising crack sensitivity, strain arising during solidification range, material types, contaminations, base metal dilutions, lowering weld strength, expansion coefficient, well cooled shape and size, depth to weld ratio, surface conduct, concavity, arc energy, solidification crack. This is longitudinal crack. This is centerline crack. This is a crack. This is a crack in the pipelines joint. Laminar tearing, separation or cracking along planes parallel to the principal plane of deformation. Occurs in rolled section, mainly, but can also occur in extrusion and forging. Does not occur in casting. Laminar tearing, this is laminar tearing, and this is also this is a laminar tearing. Inspection and testing of weld joints, destructive testing and non-destructive testing. Destructive testing, mechanical testing, basically mostly tensile test, bend test, and hardness test. Non-destructive testing, manual inspection, dye penetration test, magnetic particle test, ultrasonic test, radiography test, X-ray, gamma ray, etc. Welding safety precautions, ensuring high level of safety is vital when undertaking any welding activity. Ignoring your personal protective equipment and safe working practices can have serious repercussions and might even lead to fatalities. Therefore, one should follow the safety precautions below to protect yourselves at work. So, and sufficient air circulation is also required to, for the safety of the workmen. Thank you very much for listening.